not the best at basketball. But since ubiquitous math is about applying math in the real world, there is a way that we can get better at basketball using math, through differential equations and Newtonian mechanics. So we're going to take the standard differential equation approach to solving a problem like the trajectory of a ball. So first, let's visualize what's going on. If we have our y-coordinate and x-coordinate, then we have our parabolic trajectory. So it doesn't have to start at the origin. It could start here, or here, or here, wherever. But what to note here is that we have this angle theta here at the start, and then we have the initial velocity vector, v naught. And then, if we look at v naught, here we'll have the x component of this vector, so v sub x naught, and then here we'll have v sub y naught. And using some trigonometry, we can see that v sub x naught equals v naught times cosine of theta. Because when you think about it, the cosine of theta is the adjacent leg over the hypotenuse. So vx naught over v naught times v naught gives us vx naught. And then a similar thing is true for vy naught, only it's v naught times sine of theta. And then, to complete our initial conditions, we can say that x of 0, where the function is x of t, and then y of t, x of 0 equals x naught, and y of 0 equals y naught. So now let's construct our differential equations and figure out all the forces. So we'll be using the Newtonian Mechanics, so F equals ma. And we have the x component of the force and the y component of the force. The x component of the force is just 0 because you're throwing the ball upwards. And then the y component of the force will be negative mg. So there will be negative g, the acceleration, and then the mass. So using this information, we can construct the differential equations. First of all, we'll say x, 2 dots. So this will be the acceleration along the x-axis will equal to, so acceleration equals force over mass. So it'll be F sub x over mass. And we know that F sub x equals 0. So this will just be 0. And then we have y, 2 dots, the acceleration along the y-axis upwards, and this will equal to negative g. Alright, now to solve these very simple differential equations, we can just integrate both sides. So right here we'll have integral of x, 2 dots, dt equals integral of 0 dt, and here we'll have x dot plus some constant equals 0 plus some constant. And let's subtract this constant from both sides and call the difference between this one and that one c sub 1. So x dot equals some constant c sub 1. And then let's integrate again. Integral of x dot dt equals integral of c sub 1 dt. So again, it'll be x of t plus some constant equals c1 t plus another constant. We'll subtract this from both sides and call the difference c sub 2. Now let's solve the equation on the y side. So let's integrate. So here we'll have y dot plus some constant equals negative gt plus the difference between the constants, which we'll call c3. And then we'll integrate again. And then here we'll get y of t plus some constant equals negative gt squared over 2 plus some constant plus c3t, also plus some constant. Let's call the sum of those constants minus this constant c sub 4. Okay, so the next step would be to sub in the initial conditions that we figured out here. So first of all, we know that x dot is the x component of the velocity, v sub x. And x dot of 0 will be v sub x naught, right here. And we know from our initial conditions that this equals v naught times cosine of theta. And we also know that x dot equals c sub 1. So this will be the value of c sub 1. And then c sub 2 is just a constant. It's the initial x naught. So therefore, x of t equals v naught cosine theta times t plus x naught. Now we move on to the y equation. So, first of all, c sub 3 will be a similar story. We know that y dot of 0 will be v sub y naught, which equals v naught times sine of theta. And this will equal to negative gt plus c3. So therefore, c3 will equal to v naught sine of theta plus gt. And then, for the c sub 4, it's just a constant, our y naught. So now, our y of t will equal to negative g t squared over 2 plus v naught sine of theta plus g t times t plus y naught. However, there's one final thing to note here. Since this is at t equals 0, this gt term will also equal to 0. So really, we can simplify our y of t to be negative g t squared over 2 plus v naught sine of theta t plus y naught. And thus, we have figured out the x-coordinate as a function of time and the y-coordinate as a function of time using some simple differential equations and initial conditions. Thank you for watching. Please apply a force vector to the like and subscribe buttons, and see you next time.